We'll begin with your grade 10 mathematics. And I think the first chapter is linear systems, which we need to do.
Mhm.
So we'll start with linear systems. I hope you remember all what you learned about the lines. Do you remember?
Yeah,
Yeah.
a bit, yeah.
Okay. So we'll kind of review a bit of it and then move forward. Perfect.
Okay.
So we'll have 3 classes in a week. And
Mhm.
in between, I'm going to give you a lot of homework. So you need to do practice. Practice makes you perfect, right? So you need to practice the questions, watch some of my videos to get more concepts, and then just see how we can move forward in this way.
Yeah.
So good, I see your file and pen already. You can also keep a calculator if you want to. It will not be really required, but from tomorrow, okay? So today I'll have
Okay.
very simple concepts and we'll try to think and just, I should say, refresh
Yeah.
all about grade 9 and then move forward, right?
Mhm.
So let me share with you my screen. I got something which we could discuss today uh, about linear systems. Tell me what is the title on this page?
Linear system equations and word problems.
Perfect. So that is going to be our title for the first week, I think, at least. So we'll talk
Okay.
about, we'll touch about basics about line. We'll understand linear system. We'll solve system by graph. We'll solve by
Mhm.
substitution method. I'll also take up models which will relate to real life situations. And we'll solve some equations using elimination. And then we'll also see mixed strategies to solve linear systems. Sometimes you might even combine some quadratic functions with it to make it more complicated. And that will be part of our review and exam practice. Okay. So we'll call it linear systems. Most of the time we'll deal with 2 or more linear equations. Okay. But at the end, we'll see what happens if a quadratic equation is also involved, okay? Especially when we talk about a line intersecting a circle, forming a tangent, or it can form a chord. So those are some very interesting questions which are seen in IB test paper. So we'll touch upon that also in this particular unit. Is that clear?
Yes.
Okay, so I'll give you a lot of practice questions. You can take notes of fine points, but in all, I'm actually recording this, so we'll be sharing this particular video also later. So you'll get a
Mhm.
time to go through this video once again. Is that clear?
Okay. Yeah.
So that'll be nice. So we'll actually upload this video and it can be referred by other students also. That'd be nice. Okay?
Okay. Yeah.
No. So when we say basics, it should be S there, basics about lines. About the basics about line, we need to understand the methods to sketch graph of a line. You know how to sketch graph of a line?
Yeah.
Basically, we follow 3 different methods. One of them is table of values. Then you can use slope and intercept form of
Slope.
the equation
Yeah.
of the line. And also you can use x-intercepts and
And
y-intercepts
one.
to sketch a line, correct?
Yes.
Now here is an example for you. You can actually note the example. You need to graph each of these lines. Y equals to 2x minus 1. So that is my first line. And this equation is in which form?
Uh, it is. Oh, I forgot the name.
Slope and y-intercept form.
Slope and y-intercept form. Yeah.
What is the slope and what is the y-intercept in this equation?
The y-intercept is -1, and the slope is 2.
That's absolutely correct. So can you sketch this line and show it to me?
Yeah. Something like this.
Let's see. It looks okay. Can you describe your line and the process which you utilize to sketch this particular line?
So I took the slope that the y-intercept that I had,
Yeah,
the -1, and I started from there, and I used my slope 2x. So
yeah,
I went up. So I went up 2, and then
yeah.
to the left 1.
And then continued this process,
And then
got 4 or
continue
5
the,
points,
yes,
and
yes,
connected them to get your line. That's perfectly fine.
yes.
The second equation is 3x plus 2y minus 6 equals to 0. What is the best way to sketch the graph of this particular line?
I could simplify it into the same form as A.
Yes,
So then I could do that and then sketch it into a line.
that is one way of doing it. But that takes time. Can you suggest me
Uh-huh.
some other method which is definitely written here amongst the three choices you have? Which could be the best way to sketch the line 3x plus 2y minus 6 equals to 0?
I could use the X and Y intercept and start
Perfect.
from there.
That is the best way to do it. Because see, now the things are now in grade 10, you'll find time is a constraint. So you do not have liberty to just follow any method. You need to use the best method so that the question can be solved in minimum time. Does
Mm-hmm.
make sense, right? So that's very important. So now, how will you find the x-intercept of this line 3x plus 2y minus 6 equals to 0? Can you explain, please?
I could simplify solve for X. So do 3X is equal to, and bring the 6 over to the other side.
Yes,
And then do the same thing for Y.
correct. So the x-intercept will be 6 divided by 3, which is 2, and
Yes,
y-intercept will be 6 divided by 2, which is 3, right?
yes,
To find the x-intercept, you substituted y equals to 0, right?
yes.
So y was
And I
0,
see.
6 went that side, divided by
Yeah.
3, you got your answer as 2. To
Mm-hmm.
find the y-intercept, you substituted x as 0, so you have
Yes.
2y equals to 6 divided by
And
2
6
gives you
divided by 2.
3, correct?
Uh-huh.
And
Yes.
you got now 2 points, connecting these 2 points, you get a straight
You
line,
make a
correct?
straight line. Yeah. Yes.
Now, quickly, can you tell me what is the slope of this particular line 3x plus 2y minus 6 equals to 0? Is it positive or negative?
It would be positive.
Why?
Because when the line goes from downward up, it's positive.
No, when you rearrange, if you rearrange this into slope-intercept form, you will take 3x to the other side. As soon
And
as
then it
you take
becomes negative.
negative, right? And then you divide
Yes.
by 2. So it is minus 3 over 2. Do you get the
Mm-hmm.
idea, right?
Yeah.
So the slope is negative, and it is negative 3 over 2. So these are good things to observe when you are given an equation. Perfect? Does make sense?
Mm-hmm. Yeah.
So you're sure that, once you got these x and y intercepts and you have connected, all the things fall in place, and what you get is a perfect answer, right?
Mm-hmm.
So, I just sketched this line here. So I'm sharing with you the solution of this particular question. We had two equations to begin with, y equals to 2x minus 1. The second one was 3x plus 2y minus 6 equals to 0. Now,
Yeah.
I could also adopt this method of making table of values,
Table. Yeah.
and then we could sketch the line. So if I
Mm-hmm.
take x values as minus 1, 0, 1, 2, and 3, substitute in this equation, which is y equals to 2x minus 1, I will get the y values as calculated here
Yes.
as minus 3, minus 1, 1, 3, 5. You can notice that the y values are increasing by 2, right? That is the meaning
Yeah.
of 2x. Slope 2 means the first difference. First difference here is 2,
Mm-hmm.
right? For a straight line, the first difference is a constant. And that first difference is the slope of the line. In this case,
Yeah.
slope of the line is 2.
It's 2.
And therefore, as you move from one x value to the other consecutive value, you will get a difference of 2, right?
Yes.
So another good point to remember is that the first difference is constant means the equation is referring to a straight line, correct?
Yes.
Now, of course, I've sketched this line using your concept of y-intercept being minus 1. So the blue line goes up by 2 and right 1, you get a point, up by
Yeah.
2, right 1, you get the next point. Well, to draw a line, how many points minimum do you need?
4.
Only 2 points minimum.
Yeah.
Right. So to any 2 points, when you connect with a straight line, you get your line, right?
You get your line.
And to find a slope of a line, any 2 points on the line can work. Perfect. Correct. That's
Yeah.
all we learn. Perfect. So on a line, we just need 2 points. Always we are looking for 2 points, right? Normally, the very first point is the y-intercept, easy to calculate, right?
Mm-hmm.
The other point could be x-intercept, as we have seen in the second equation. So second equation is given to us in standard form. 3x plus 2y minus 6 equals to 0. That is the standard form of equation. And in this standard form, the value of a, which is 3 in this case, cannot be negative. Remember that part, right?
Yes, because
So it is ax plus by plus c equals to 0, where a is not a negative value. Second, we also prefer the value of a to be a whole number. You understand?
yes.
A to be a whole number, that is also preferred. We don't want fractions there. So if I have a value of a as like 1 over 2, we'll prefer to multiply the equation by 2 and keep a as 1. Is that clear to you, right? So always when you write your answer, it's very important to understand sometimes in the question, it is stated that write the equation of the line in standard form. So if it says standard form, it really means that the value of a should be positive and a whole number. Okay?
Yes.
And all the terms on one side equal to 0 on the other side. Is that okay? So that is how you have to write an equation in standard form. Now, I've shown here the steps involved to find x and y intercepts. So for x-intercept, you need to substitute y equals to 0 in your equation, right? And once you do that, you get the value. For y-intercept, substitute x equals to 0. And once you do that, you get the value for y-intercept, which is calculated here as 3. So you got these 2 points, 2 and 3. Once you get these points, just connect them with a straight line. Is that correct?
Yes.
Right. So that is how we can actually graph our lines. Now that brings us to the topic, which is linear systems. Now, what does it mean to you, the linear system? Can you guess and tell me kind of what is a linear system?
A linear system is when you have 2 equations, but they're both quite the same.
Okay, so you're quite right. Linear system will involve more than one equation. It could be 2, 3, or whatever, but a system is formed when we have more than one, right? So till now, we had been working just with one equation, right? In grade 9 and doing everything. Now we have 2 equations to work with, and these 2 equations, linear equations, will form a system. Now, here you can see we have 2 linear equations on a particular graph, and they do intersect at a point, correct?
Yes.
This point where they intersect is called the solution of a linear system. Is that clear? So a linear system can have a solution. Is it possible that the linear system may not have a solution? What could that be?
Yes, because there could be a dependent and an independent, and then there's one more. I forgot the name. There's independent, dependent, and then one more.
So you have learned a bit about it. So when did you learn about dependent, independent?
I watched some of your videos on the linear system and equations.
That's very good. That's very good. Well, we'll touch upon these topics now when you have referred to them. Let me give you some terms. I was not really planning to tell you those terms today, right? But anyway, it's very good that you have gone through some videos and you have good knowledge about it to begin with. Now, let me give you, first term is consistent, right down, consistent. If a linear system has a solution, then we say that the linear system is consistent, right?
Yes.
That is the very first thing. Inconsistent, well, the linear system does not have a solution, right? Okay, so that is one thing. Now, can you tell me an example where the linear system is inconsistent? Let's say we are working with this particular line, y equals to 2x minus 1, which is represented on this graph with a blue line. Now, I want to make a linear system which is inconsistent with this line, y equals to 2x minus 1. How am I going to do it?
You could have, let's say, 1x or x, because then it would run parallel with any y, another y-intercept.
Parallel means same slope. So you have to maintain the number 2x. You understand? But you can change that minus 1 to plus 1, 3, 2, 5, whatever. So yes, you're right. So if you have another equation of line which has the same slope as y equals to 2x minus 1, then the system form will not have any solution. Those lines are going to be parallel. So their slope should be same and y-intercept should be different. So the equation could be y equals to 2x, y equals to 2x plus 1, 2x plus 3, 2x plus 3, 4, 2x plus 5, whatever, but not minus 1. Do you see that?
Yes.
Okay.
Yeah.
Now we will go to the other point, which is consistent. Consistent means it has a solution. So if I have to write an equation which can form a system which is consistent with y equals to 2x minus 1, what could be my equation?
You can have a difference. So you could have, let's say, 4x minus 1.
That
has the same
change the slope. Change the slope.
Yes.
Rest doesn't matter. Y equals to 4x, y equals to half x, y equals to 2x, not 2x, right? Something else, but not 2. Is that clear?
Yes.
Y-intercept could be any value. Doesn't matter, right? Is that clear to you? So you can have a general equation as y equals to ax plus b, where a is not equal to 2 in this case, and b could be anything. Is that clear to you? So you can form many equations which will be consistent with the given equation. Now, very important thing is a question to you. Now, listen carefully. I have the same equation, y equals to 2x minus 1. Now, if I have another equation of a line which has exactly the same slope as 2, right, then can I have a system which will be consistent?
No. If there is a bent line.
Is there a?
If there's a curved, no, but then the slope would be different. No, you can't.
Okay. Now, if I have the other line which is exactly the same, 2x minus 1, I may rearrange it. You understand my point? I could have 2x minus y minus 1 equals to 0. It is actually the same line. So if I have exactly the same line, it will overlap. So if it overlaps,
and it'd be no solution.
There will be infinite solutions.
It'd be yeah.
Because they're overlapping and they're matching up at each and every point, right? So there are infinite solutions since the line has infinite points. Do you get the idea? So still, because they have solution, I was using the word A earlier, but that's like misguiding you, okay? Confusing you. It should not be used, right? A line over another line will have infinite solutions.
Infinite solution, okay.
Since they have solutions, right?
Yes.
It means consistent. But the thing is, they have infinite solutions. There's something different about it, correct?
Yeah.
The two lines actually are dependent, we say, right? Because the other value is kind of dependent on this. Is it?
Yes.
Right? They are not independent lines. They're exactly the same lines. And that is how we get the other term, dependent and independent. Correct? You get an idea, right?
Yeah.
So that is how the other term comes into place, sometimes confusing. So what do you notice from today's lesson on this lines? If there is a system, a linear system, in that case, how many solutions can a linear system have?
3.
3. So what are these 3 solutions?
Dependent, independent, and infinite.
Okay. So one solution is no solution. Okay, one solution is they are parallel. Right. 3 is correct. One solution is they are parallel, correct? So they have no solution. That is also a solution, right? We call this as inconsistent. Is that clear? Inconsistent, right? Now, second, we have a solution, that means it is consistent, but the solution is either a point or infinite points. Does it make sense? If it is one point, we say independent. If it is infinite points, we say dependent. Is that clear to you? But there are 3 types of solutions. One is no solution, one is one solution, the other one is infinite solution. So if a linear system has a solution, it really means that their slope is different.
Different.
One solution means the m value, the slope is different. The gradient is different for both the lines. Is it clear?
Yeah.
Now, if the gradient is not different, means if the gradient is exactly same,
Same.
then there could be two conditions. One,
Yeah.
they could be parallel. The other, they could overlap.
Yes.
If they are parallel, then they don't have any solution.
Yeah.
But if they overlap, they have
There
infinite
is.
solutions.
Yeah.
So we have three different cases. Is that clear to you?
Yeah.
Perfect. So can you summarize what all did we learn so far?
So we went over just the simple basics of what we learned in grade 9. And
Yeah.
then now we learned how to add two equations, or two lines in this
Yeah.
case,
Yeah.
into, and then solving for different solutions,
Correct.
if there is.
Correct. So basically we learned that for the lines, you could actually graph a line using table of values. You could
Yeah.
graph a line using slope and y-intercept. You could also graph a line using x-intercept and y-intercept, right?
Mhm.
If you have an equation which is already in slope and intercept form, the best way to graph definitely is to use slope and intercept form, right?
Yes.
So you
Yeah.
go to the y-intercept, then go with the slope, get all the
Slope, and
points,
then go
and there
there.
you have a line. But if you have the line in a standard form, the best way is to find the x and y
Solve for.
intercepts and then connect those two, forming a line. So that is one thing which we've learned. Now, once we have these lines, as we can see here, we can actually make a table of values, which does take a lot of time, not a very good approach, but it is
Yeah.
definitely an approach. You can always have a table of values also to connect these points and form a line. Now, a linear system will be a system which will have at least two lines. It could have more than two lines also. As you can see from this particular graph, we have two lines and they intersect. If these two lines intersect, then we say that the system is consistent. We have a solution. In this case, we have exactly one solution. Now my question is, why can't a system have two solutions?
Because then there would need to be 2 points
Yeah.
of
Yeah. Why
intersection
can't
with
they
two
meet
lines.
at 2 points? Yes.
Because then the line wouldn't be straight.
It has to bend, right? So
Yes.
once it crosses the other line, it has to come back and cross the line. But lines go straight in one direction. They cannot bend, and therefore there is no possibility of having two solutions. So basically, we learned that there are only three types of solutions. Either we don't have any solution, right? That's the
Or
solution.
there is.
Or
Yeah.
we have one solution, or we have infinite solutions, right? Now, if you have one solution, that clearly means that the slope or the gradient of the lines is very different. It's not same, right? But if you have one solution, I mean, if you have one solution, means the gradient is different, the slope is different, and they will intersect definitely at one point. However, if they have the same slope, then it really depends on the y-intercept. If
Yeah.
they have the same y-intercept also, the lines are exactly the same.
And then that's
They have infinite solutions.
infinite.
But if the y-intercept is different, then they are parallel lines and they'll have no solution. Correct? So that is how we were getting the terms, which are slightly confusing to begin with, consistent and dependent. However, we are going to use these terms later to a large extent, and especially in multiple choice questions. Okay? Now, easy way to find x-intercept, the way to find x-intercept is definitely substitute y equals to 0, right?
0.
And
Yes.
then solve for x. And to find the y-intercept, substitute
So
x
x
equals
for
to
0.
0 and solve for x, correct? So that is how you do it. Now, let us also look into the process of finding equation of a line. Now, if I give you 2 points, let's say this equation, this particular question, example 2 here is, write equation of a line passing through the points A, -1, -2, and B, 1, 4. How will you write this equation? Can you explain?
So first I could do y2 minus y1 over x2 minus x1, and then I get my slope.
Yes.
And then I can use my slope to find my y-intercept.
How?
I just substitute, so I have my mx plus b.
Yes.
And then when I plug in the two numbers on the graph and I
Any
go
one
down.
point you could select, yes.
Yes, and then I use that to find.
Can you tell me alternate way of getting the equation of a line, and that too in standard form? So in our schools in grade 9 specifically, we are not focusing on the point slope form of the equation. We only focus on slope and intercept form, which we explained, y equals to mx plus b. So you find slope y2 minus y1 divided by x2 minus x1, then use the slope at a point to find the y-intercept, and you get your equation. In this case, we get the equation as y equals to 3x plus 1, correct?
Yeah.
Now, here is an alternate method which you should very closely look into. The formula is kind of related with y itself, slope itself. See, m is y2 minus y1 divided by x2 minus x1, correct? If I cross multiply, I get what? I get m times x2 minus x1 equals to y2 minus y1. Do you see that?
Yeah.
Right? So if I say my x2, y2 are points x and y, then I can write this equation as y minus y1 equals to m times x minus x1. Does it make sense to you? Do you see that? The same equation of a slope which you used, when we cross multiply, we get m times x2 minus x1 equals to y2 minus y1, right? So I can write this as y minus y1 equals to m times x minus x1. This form of equation is called point slope form, because we know a point. In this case, we are using point B. We are writing that point as x1, y1. We know the slope m, which was calculated as 3. So if I substitute those values, I get y minus 4 equals to 3 times x minus 1. And now, distributive property, open the bracket, multiply 3 with x and minus 1. You get y minus 4 equals to 3x minus 3. Put them all together. You get your equation standard form, which is 3x minus y plus 4 minus 3 will give you 3x minus y plus 1 equals to 0. Does it make sense to you?
Yes.
It does, right? This is a very good form of an equation and should be utilized when need be. I'll tell you when the need will be. Let us say you have a slope as in a fraction form. Let's say you get a slope of 5 over 2, right? Let us say, right? Now, if you substitute in your y equals to mx plus b, 5 over 2, and then you substitute x and y values, you're dealing with fractions, correct?
Yeah.
This becomes difficult. Now, in this particular equation on the right-hand side, if I write 5 over 2, you multiply the x values by 5 and cross multiply the y values with 2. You have a linear equation always to work with. Much, much simpler. Do you see that part? So moving forward, you'll find that point slope form is a much better equation to do. Second, you don't really have to reorganize and write it in standard form. If, as in many cases, the equation will be, write your equation in standard form. Use point slope form and write it in standard form. Does it make sense to you?
Yes.
Correct? So that's a very important equation to always utilize. So is that part clear? So have you made a note of this particular equation?
Yes. Yeah.
Very good. So that's kind of important to us. So we are almost at the end of this lecture. It was supposed to be half an hour lecture, right? Now here is a question for you, from where we are going to continue tomorrow. The question is, solve the following set of equation by substitution. And we have y equals to 2x minus 1 and x plus y equals to 2. Right? So yes. So what you could do here is that we could actually solve this equation by substitution, right? So tomorrow we'll see how to do it. But you can see right here, y equals to 2x minus 1, and the other equation is x plus y equals to 2. So you could substitute the value of y, which is 2x minus 1, in the second equation. So you get equation in one term, which is x, which you can actually solve and get your answer. Is that clear to you? But today, we had focused on how to graph and then find the solution. So same question I'd like you to do today using a graph. So I'd like you to sketch the graph of y equals to 2x minus 1 and x plus y equals to 2. So when you sketch, they will intersect at one point. You can clearly see that the slopes are different, right? And you have to figure out what is this point or what is the solution of the linear system. Is that clear to you?
Yes.
as an added exercise, what you can do is you can check your solution. That is to say, whatever point of intersection you get on the graph, substitute it back into these two equations and see whether the left side is equal to right side or not. Is that clear?
Mm-hmm.
So checking a solution means once you get a solution as a point on the graph, then plug it back into the equation and see that the left side is equal to right hand side. If that is the case, that is the right solution. Both are equal, right? So that's what it means. So is that clear to you?
Mm-hmm.
Now graphing and then getting the solutions is not always the best method. Since you can see the very first example we had, can you tell me what is the solution of this set of equations? Y equals to 2x minus 1 and 3x plus 2y minus 6 equals to 0.
It is a dependent solution.
I mean, can you read this point from the graph where they intersect? Very difficult, right?
One point, like
something,
two,
right?
Yeah.
Not very accurate.
And,
not very accurate. Similarly, the y point is not very accurate, right? So,
yes.
I mean, approximately you can get a solution. So that is the difficulty with getting solutions after graphing the lines. So definitely we need to do some algebraic methods to find the solution, right? So the two methods which we'll actually work on are one called substitution method, for which we have just talked about, and then later elimination method, but they will give you the exact point. These are helpful, especially if you have solutions where we have fractions involved, right?
Yes.
Okay, that's the kind of thing we have. And you can see advantages and disadvantages. It is easy to get a solution graphically. Don't have to do much, just sketch the lines and you can mark this particular point. However, it may not be easy to read the solutions at times because of the points, right? So, suppose if I have 1 over 3 as my solution, it's so difficult to read from the graph, for example, correct? So that is one particular thing which we have to keep in mind. Perfect. So I think we have understood about some basics about the line. We understand what a linear system is. We also know how to solve a system by graph. So these 3 points we have covered today. The last thing is solve by, the second major thing is to solve by substitution. And then we look into solve by elimination. In between, we'll look into models which can help us write real life situations into form of a linear system and then solve them, right? And then we'll end up with an exam review where we'll take up some difficult questions. Is that clear?
Yeah.
Okay, Nick, so let's wind up. I would like you to tell me in short, what have you learned in today's lecture and what is your next goal?
So today we learned about the basics of linear systems and like different ways on how to solve it and different solutions that there is. And then we learned about a new form called point slope form and how using that when there's fractions is easier. And then a little bit into substitution.
That's perfectly fine. So as far as your homework goes, I'm going to send you about 20-25 questions. I'd like you to go through those questions, share your solutions with me. I'll also share with you some of my videos as I did earlier, so that you better understand all the terms, make your notes, and then tomorrow we'll take up the method of substitution and we'll model real life situations to find solutions. Does that sound good, right?
Yes.
Okay, great. Thanks.
Okay, bye, sir.
Back.